Hello everyone, welcome to the channel. This video covers machine learning end-to-end pipeline. First we'll look into entire flow of machine learning pipeline starting from data labeling, then machine learning algorithms, supervised, unsupervised and reinforcement learning, then applications of machine learning algorithms, then model training, testing and finally evaluation of model. What is machine learning? Machine learning is a set of algorithms used by machines to learn from data, identify patterns in the data, and predict unknown data. Machine learning is a concept of machine that can learn to achieve goal on its own. What do I mean by learning in ML? Learning is gaining knowledge by experience or being taught. A machine, let's say a computer, learns something about the structural description from raw data. First step in machine learning pipeline is defining problem statement. For example, identify car in a picture. Then collect relevant data, clean the data, and label the data. Next comes feature engineering or featureization. This is important concept in machine learning. If you are new to machine learning, then please pay close attention to this term feature engineering or featureization. Feature engineering converts string data into numerical data. Why we need feature engineering? Why can't we just feed raw data as it is in the form of strings to machine learning algorithms? The issue is machines like computers does not understand strings. Machines understand only numbers. Machine learning is based on mathematics, that is solving set of equations using linear algebra. The equations expect numbers as input, so we need a way to translate the raw data into set of numbers. For example, raw data would be iris data or data from ImageNet or the data from the internet. This data is translated into numbers and then into matrix form and vectors. Then machine learning processes this data in rows and columns by applying machine learning and mathematical equations. Next step is training model. Train model by applying rules to known data to predict unknown data. Here, what is a model? A model is nothing but structural description of raw data. Model contains information extracted from raw data. Once the model training is successful, evaluate the model performance. Check whether the model is able to identify the objects correctly. After model evaluation, deploy the model. If the model performs well, then deploy the model, else retrain the model. Now let us look into each of the steps of machine learning pipeline in detail. Starting with data labeling. We have raw data, unlabeled data, and labeled data. What is raw data? Raw data is direct from the source without any structure. Unlabeled data is bit structured but lacks specific tags. Labeled data requires more effort as raw data needs to be converted to labeled data for more accurate predictions. Hence, labeling needs significant effort and high cost. In this slide, the cars are not labeled, so these are unlabeled objects. And then next, the cars are labeled as SUV, electric car, and sports car. That is, each object has been given a tag. So this is label data. Labeling can be on images to identify the objects in the images like computer vision. Labeling can be on text to identify parts of speech, intent, like in natural language processing, NLP. Labeling can be on audio to identify noise like sound alarms or birds noise. For audio labeling, first step is to transcribe audio into written text and then proceed with machine learning pipeline. Why label data? Why can't we use raw data as it is? The machine learning model uses these labels to learn the patterns in a process called model training. The result is a trained model used to make predictions on new data. The next question is, who labels the data? Labeling can be manual or automated. Labeling is done by humans by asking questions like whether a photo contains a car or not, whether an object is a two-wheeler or not. Now, labeling is also done by AI assistants or AI tools. To summarize data labeling, once the raw data is collected and cleaned based on problem statement, based on availability of human resource and AI tools, considering the cost of labeling data, the person working on ML problem statement decides whether to use unlabeled data as input to machine learning algorithms or use labeled data as input to machine learning algorithms. Next, let us look into machine learning algorithms. Though there are 14 types of machine learning algorithms, ML algorithms are broadly classified into three categories. The most widely used machine learning algorithms are supervised, unsupervised, and reinforcement learning. Unsupervised learning. What is unsupervised learning? We may not have large amount of labeled data or we quickly want to perform an experiment on a set of data. In those cases, we opt for unsupervised learning. Unsupervised learning is an algorithm whose input is unlabeled data and it does not have any specific target output. This algorithm has input but no corresponding output. Algorithms learn on their own and present interesting structures in the data as output. For example, 1 million customer reviews from an online shopping is unlabeled data in big cluster. Unsupervised learning understands the structures in this customer data and further divides the big cluster into small clusters based on customer review comments. Now let us see what is supervised learning. In supervised learning, an algorithm whose input is a set of labeled data, like we saw in the previous slide, labeled data, where cars are labeled as sports car or electric car. This labeled data is the input and output is labeled predictions depending on model training. For example, emails can be labeled as spam or non-spam. Another example, we have a category vehicles and transport system. Unsupervised learning identifies the broad category of transport vehicles as two-wheeler, three-wheeler, or six-wheelers. Unsupervised learning identifies specific category like cars from four-wheelers. We also have something called semi-supervised learning. In semi-supervised learning, we have small amount of data which is labeled and large amount of data which is unlabeled. This is used in medical analysis to diagnose a disease where there is limited data during initial phase of diseases. Then comes reinforcement learning. In this, agent learns and make decisions through trial and error in feedback loop with rewards and penalty. Like in self-driving cars, the car finds the way by observing the roads, playing games like chess or some video game in real time. In the games, the user has to make movements based on opponent action in real time. So reinforcement learning mainly works in situations where there is lot of exploration. Reinforcement learning uses agents and rewards techniques. We will see this reinforcement learning in detail in next slide. Let us compare and contrast supervised learning, unsupervised learning, and reinforcement learning. Both supervised learning and unsupervised learning are static functions. Both supervised and unsupervised is a sequence, meaning unsupervised learning takes unlabeled data and then output the clusters. In supervised learning, the input is labeled data and output is also a labeled data with specific tags. Unsupervised learning finds structures like customer segmentation based on customer buying pattern. In supervised learning, for every car image, there must be an input labeled car. In supervised learning, for every dog image or cat image, there must be an image labeled dog or cat. Some more examples of supervised learning are stock market. Supervised learning can predict tomorrow's stock price, whether the price might go up or down based on today's market situation. In reinforcement learning, it is a time-based function with feedback loop. Reinforcement learning can plan for future. What is the meaning of time-based in reinforcement learning? Imagine a self-driving car simulation. At each point in time, we can decide what to do next. Whether we want to take a left turn or a right turn based on our destination location, or based on the traffic condition in real time, whether to apply a brake or increase the speed. Reinforcement learning learns from trial and error. Let us look into the terms which are used in reinforcement learning. What is state, what is agent, reward, penalty, and environment in reinforcement learning? State, action, and rewards. These help us describe how the agent and the environment interact with each other. For example, in chess game, the situation is whether to move queen or not to win the game. In this example, agent is a machine or a computer program that is learning chess game. Environment is the world or the game that you are teaching your agent to win. Now state is each location. For each location, let's say a square on a chessboard. Is there any obstacle if I move a queen from one square block to another square block on a chessboard? Now next term is action. Action is what agent does in environment by observations like whether to place the next move in chess or not. Reward. Reward, a number that agent tries to maximize. Reward can be positive, negative or zero. Reward is performed at each step of the game. You can assign the reward to improve training. Is this a good reward? Minimize loss but maximize reward for good algorithm. Now coming to the applications of unsupervised, supervised and reinforcement learning. There are several types of unsupervised learning like clustering, k-means, FP growth algorithms, dimensionality reduction, principal component analysis PCA. Now coming to the applications of unsupervised learning, let's say a person X buys a product, then person Y also tend to buy the same product. Unsupervised learning is used in customer segmentation, identify purchasing behavior, in recommendation systems, and in social network platforms. Unsupervised learning is less expensive, so it less time consuming as no need to label data. The disadvantage of unsupervised is noisy data and may lack clarity in clusters. Now coming to the supervised learning types are classification, linear regression, decision trees, random forest, SVM, KNN, K nearest neighbors, naive Bayes. What are the applications of supervised learning algorithms and its types? Logistic regression classifies email into categories like family, friends, social. Linear regression use cases like house cost prediction based on area and number of rooms. Naive Bayes classifier classifies email from spam and non-spam into spam email different for different person. What is spam for a person X need not be spam for person Y. In K nearest neighbors, use case is recommendation system. Please note, recommendation system use both supervised and unsupervised learning. If the object is to identify the patterns or clusters of similar users, then unsupervised learning is used. If the use case is about recommending products based on user preferences like rating, clicks, then it is recommendation system based on supervised learning. Recommendation systems are typically classified as hybrid as they use both supervised and unsupervised learning based on the use case. Supervised learning advantage is high accuracy and less processing time as the data is labeled, but labeling itself may be time consuming. As the data needs to be labeled by human resource or by AI tools, supervised learning is expensive. Next, types of reinforcement learning are model-free Q learning or model-based learning. And the applications of reinforcement learning are in robotics, self-driving cars, games like chess, video games in real time. The advantages of reinforcement learning are learn from real-time interactions, does not require label data. The disadvantages of reinforcement learning are computationally intensive, reward function design, and it needs more processing power. Now let us look into ML model training, testing, and evaluation. The first step in model training is to split the training data into n number of splits and then separate the splits into training group and test group. Then train the model on training group, then test the model on test group. Ensure that the training data has good quality training to avoid bias in the model. Generally, the data set is split into 80% of training group and 20% of test group, or it could be 70% of training group and 30% of test group. For more generalized results, data can be divided into more than two groups and rotate as training group and test group. Rotate the splits between the two groups, training and test, many times until all variations of the two groups, training and test, are exhausted. This process is called cross-validation or rotation estimation. Certain parts of training data can be held out, which can be used as validation dataset during training. Then training can be performed with full data, that is complete batch training, or with a small size of data like batch size of 100 or 200 and so on. Once the training is complete, then the next step is evaluating the model. Evaluating model is the process of understanding how well the model gives the correct results and then measuring the value of prediction on a certain context. Basic tools like confusion metrics are used for evaluating the models. We will look into the confusion metrics in detail in advanced concepts of machine learning video. Observe if any errors in the training, test and validation data group. Check for generalization issues, bias, underfitting and overfitting. What is underfitting? In underfitting, the model does not respond well to both training data and test data. That means model needs to be trained with more samples to avoid underfitting. If training data group accuracy is good, but test data group accuracy is not good, then it is underfitting. Then it is overfitting. That means in overfitting, the model responds well to the training data and not to the test data. Low error rate for training data but does not generalize for the data we are interested in is overfitting. Now let's say we have data images of vehicles, two-wheeler, four-wheeler, six-wheeler. If we want to identify the car using image classifier, in the data set there could be images that are blur, distorted images which appear to be image of car but not car in reality and other way around. Now split the image data into training and test groups. Randomly shuffle the data. Train the model to identify car in the images. Evaluate the model with training group and test group and check if model is performing well. Let's say if model makes huge errors and not identifying the car in the image or identifying a two-wheeler as a car, what should we try next? Do we have to get more training examples? Do we have to check if collecting more data helps? Is data labeled correctly? Check for noisy or incorrect data labels, such as a car may be labeled as a truck or a car is labeled as a cycle. Then reduce the incorrect data labels. Try small set of features or try getting additional features by decreasing or increasing features. Then again test the model for underfitting and overfitting. This brings us to the end of the video. I hope this video is helpful. See you in the next video. Please don't forget to subscribe to the channel and let me know your comments. Thank you for watching.